I guess it's fair to say that a lot of blood, sweat and tears went into each single component, its design, the concepts and the manufacturing after all. If you imagine that just 1 year ago, none of this was reality, just blank papers, and now we are actually able to show you a fully functioning Hyperloop prototype. It's just great to see how everything is coming together such nicely. But now, enough talking, let's have a look at the components.
I'm one of the founders of MuZero Hyperloop, and I saw the opportunity to create something completely new, something with substance, and the opportunity to work with people with an incredible willing.
When Olaf and Leo told me they wanted to found MuZero Hyperloop, there was no question whether to join them or not.
I was very hyped from the beginning.
Coming from the aviation industry, I'm very aware of the passenger growth at airports and the resulting capacity constraints. So I was very interested in the Hyperloop as a sustainable substitute for short-haul flights.
To me, it felt like a once-in-a-lifetime opportunity. I had the honor to lead a team of about 20 people, and when do you have this chance?
It's the practical skills which are not taught at uni, but you can learn them at such student groups as MuZero, and it really helps you later in the job get your work done.
So from the tools, I got to do 3D printing again. I haven't 3D printed in a very long time. What's exciting is that we can be very flexible with it, so we can change the design last second and still have the capacity to manufacture in-house.
What makes it fun is just the people at MuZero. It's just fun to work with them.
We talk a lot to each other, have a lot of team building, even with the digital work.
And when I had the chance to join MuZero, I just had to take this opportunity.
We have grown into a little MuZero family. It's so much fun working with all these people.
I learned to work together with people with completely different background and knowledge set.
We have people from different fields of studies, cities or even countries.
We welcome everyone, it doesn't matter what background you have.
There were quite some astonished and thrilled people who couldn't believe what we have achieved in such a short period of time. And of course, that's a great confirmation for the hard work we are putting in the project, and also it motivates us to keep going.
We're a bunch of open-minded,
International,
Ambitious,
Focused,
Hardworking,
Funny,
Diverse,
Familiar.
friendly and just amazing.
students who work on a common goal.
building the Hyperloop prototype.
I guess it's fair to say that a lot of blood, sweat and tears went into each single component, its design, the concepts and the manufacturing after all. If you imagine that just 1 year ago, none of this was reality, just blank papers, and now we are actually able to show you a fully functioning Hyperloop prototype. It's just great to see how everything is coming together such nicely. But now, enough talking, let's have a look at the components.
one of the founders of MuZero Hyperloop, and I saw the opportunity to create something completely new, something with substance, and the opportunity to work with people with an incredible willing.
When Olaf and Leo told me they wanted to found MuZero Hyperloop, there was no question whether to join them or not.
I was very hyped from the beginning.
Coming from the aviation industry, I'm very aware of the passenger growth at airports and the resulting capacity constraints. So I was very interested in the Hyperloop as a sustainable substitute for short-haul flights.
To me, it felt like a once-in-a-lifetime opportunity. I had the honor to lead a team of about 20 people, and when do you have this chance?
It's the practical skills which are not taught at uni, but you can learn them at such student groups as MuZero, and it really helps you later in the job get your work done.
So from the tools, I got to do 3D printing again. I haven't 3D printed in a very long time. What's exciting is that we can be very flexible with it, so we can change the design last second and still have the capacity to manufacture in-house.
What makes it fun is just the people at MuZero. It's just fun to work with them.
We talk a lot to each other, have a lot of team building, even with the digital work.
And when I had the chance to join MuZero, I just had to take this opportunity.
We have grown into a little MuZero family. It's so much fun working with all these people.
I learned to work together with people with completely different background and knowledge set.
We have people from different fields of studies, cities or even countries.
We welcome everyone, it doesn't matter what background you have.
There were quite some astonished and thrilled people who couldn't believe what we have achieved in such a short period of time. And of course, that's a great confirmation for the hard work we are putting in the project, and also it motivates us to keep going.
We're a bunch of open-minded,
International,
Ambitious,
Focused,
Hardworking,
Funny,
Diverse.
Familiar.
friendly and just amazing.
students who work on a common goal.
Building the Hyperloop prototype.
Emissions of greenhouse gases need to peak within the next 3 years if we're to stave off the worst effects of climate change.
Now to a dire warning. According to a new report, experts say that we have until 2030 to avoid catastrophe.
Which has infected hundreds in China, has now reached the United States.
The world is changing and we are right in it. Welcome to the Hyperlaunch 2022. This is Marina Hartmann. She is usually the technical lead of the cooling system, and I'm Michael Morisch, usually the business lead. Today, you will experience the team spirit and the passion that pushed us for the last 10 months. Day to day, night to night shift. You will learn about what helped us to develop our both loved prototypes. But first of all, what is the Hyperloop?
The Hyperloop concept is part of the fifth dimension of transport. Basically, we're talking about a capsule which is floating through a partially vacuumized tube. We are facing many challenges. That was our opener. And the pollution that is caused by travel and transport is a high-impact domain. We all know the benefits and the nice travel that we get to do with planes. It's really fast, but once you step into the plane, you also have all the high emissions in mind. If you go by train, it takes way longer, but nevertheless, it has lower emissions. And exactly at that point, the Hyperloop system steps in. The Hyperloop system combines the advantages of plane and travel. We can reach up to 1,000 kilometers per hour of travel speed. How do we do that? The resistance is minimized. Firstly, the resistance between the track and the capsule. There is close to no resistance because there is no friction between track and capsule because the capsule is levitating above the track. And secondly, there also is no air resistance. By providing a vacuum environment with the vacuumized tube, there is also no pressure, and therefore we also don't have no air resistance. All in all, the Hyperloop system is energy saving, low emission, and an environment-friendly system. Due to the high velocities, we could connect all the cities in Europe way more close. Just imagine having your morning coffee in Paris, have a dip into the sea in Barcelona in the evening, and then go for a really nice party in Lisbon in the evening. Sounds nice, right? This is not the only use case. We also need to have a look at the cargo as one use case. Only like that we can have an economic impact and with that further drive the innovation. We, the student association MuZero Hyperloop, do exactly research on that topics. We drive innovation and find solutions for all these demanding questions. We already did that last year. Let's recap that.
MuZero Hyperloop was founded in 2020. You all know it during challenging times. Nevertheless, we achieved great. The team was able to achieve the 4th place at the European Hyperloop Week last summer. It was amazing. They won the Kickstarter prize for Best Newcomer. We all are amazed. But let's have a look at our current season. I'm happy to say that we went from strangers to real friends. We are MuZero Hyperloop, and this is our second story.
I wish I was going for a party after this, but no.
I wanted to join MuZero because I want to be a part of shaping the mobility of tomorrow.
Here we are actually concentrate on some different problems and solving these problems like environment, climate change.
MuZero, I've learned to work in a team on a real project and to deal with obstacles and challenges which occur and you are not confronted with in lectures.
MuZero offers you a lot of possibilities and a lot of liberty that allows you to make basically whatever you want.
I think MuZero gives everyone the opportunity not to learn technical skills, but also to develop personally and learn a lot of skills you can't learn during your studies. Just by working together with a really interdisciplinary team from different backgrounds, different nationalities, different universities, and it's just really great to see how all of it came together so nicely.
I had the honor to be part of the founding team, and it's so incredible how the whole team evolved over the past 1.5 years. And it's so great to see what we have right now. So we achieved lots of achievements in the competitions at Valencia, and it's also great to see that we have right now a fully functioning office space. And we have a great team that is committed and that really wants to change the future.
With MuZero, I associate two different things. On the one hand, all the people there. A lot of skilled people, a lot of smart people, and also a lot of ambitious people. But also on the other hand, it's a great opportunity to transfer the gained knowledge at university to real-life projects.
My reason to join MuZero was because I saw the potential of an amazing activity, an amazing thing, an amazing group that can achieve something greater by working together.
I joined MuZero because I thought of the great opportunity to work in a team, to build something really extraordinary, which you won't have the possibility in later times in your life.
All these challenges we face every day gives them the opportunity to surpass themselves and grow beyond them. And I'm really thankful for all the team and all the commitment they put in day and night. To make our dream, our goal possible.
For me, MuZero in one word is passion. I would say adventurous. I choose challenge.
I would describe it as innovative.
Curiosity.
Friendly.
Definitely team effort.
Groundbreaking. Is that 2 words?
One and a half years ago, we had the dream to change the mobility of the future. But the cool thing is that right now we still have the same dream, but it's also way more than that. It's our mission. And I think that with all the workbenches and with all the equipment and with the great team we have in Karlsruhe and in Stuttgart, we really are pursuing this goal, and I think that we can achieve some great goals in the future.
I am MuZero.
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 We are one team. I'm proud to say that we are the team of the land Baden-Württemberg. We're not only based in Karlsruhe, but also in Stuttgart. Our members study at the KIT, University of Stuttgart, Hochschule Karlsruhe, but also at the Hochschule der Medien in Stuttgart. We are divided by the field of studies, but united by the passion to innovate. Let's have a look how we work together in our office.
Impacting the future of mobility to connect people fast and sustainably by building Hyperloops is a huge challenge. United as a team of passionate students from Karlsruhe and Stuttgart, it is our mission to tackle this challenge by building prototypes. But why? Because we are MuZero Hyperloop.
Realization of the Hyperloop concept, various disciplines have to work together. And I mean not only engineers from different faculties. For successful innovation, business models has to develop and a social acceptance is necessary. So, working in the team of MuZero, students can gather as much experience as possible during the time. So we are very happy to collaborate with the young student team, MuZero, as a part of Baden-Württemberg.
Thanks, Sandra. Let's bring the Hyperloop concept into reality together. We are hyped. You too?
How hyped are you? This is the question that we always get asked after our team meetings. I hope right now all of you would answer a 10 out of 10. At MuZero, we take that hype and develop cutting-edge technology. Based on the outstanding achievements from last season, we transferred that knowledge and now took the engineering one step further. For that, we had to do a technical deep dive and look for some innovative solutions, and I think we found some quite good ones. Now, it is your turn to dive into the technical world of MuZero Hyperloop.
I love it. Every time I see the pod, it is amazing.
Well, Micha, I can still remember the moment you saw the fully assembled prototype for the first time. His eyes were shining. More than 15,000 parts, over 12,000 files in our file management system, and over 18,000 working hours. All that came together, and we are now proud to stand here and today present you our pod. In the beginning, back in September last year, there were only a few boundary conditions given. The first one was that our track has to be made from aluminum and also shaped as an I-beam. We wanted to do a scaled prototype, and it was our goal to reach higher velocities than the season before. To do so, it was necessary to have a more stable pod at higher velocities during the run. And for sure, to not harm anything or anybody, it was necessary to develop an inherent safe system. Finally, we can now talk about the engineering behind our pod. And for that, please welcome our technical pod experts, Tobias Wittmann, Jonas Schierer, Pirilcio Keskina, and Marius Fischer.
At the core of our pod, a linear induction motor, or simply called LIM, is placed over the aluminum rail. For those of you who may not be so familiar with the Hyperloop concept, you may be wondering, so how does such a linear motor actually work? Imagine taking a more conventional rotational electric motor like you would find in your car, you cut it open, roll it out and stretch it a bit, you arrive at the geometry of the linear induction motor. And then, similarly to the motor you just kind of mentally cut open, when a current is applied, a magnetic field wave is generated that travels from the front of the stator to the back. When this wave travels faster than the movement of our pod, a thrust force is generated, further accelerating us forward. During the design process, we realized that what really brings our pod up to speed is if we can sustain high thrust forces through a wide range of velocities. Therefore, by applying design methods that are usually used in rotational machines, we were able to optimize the size of our coils to achieve the maximum velocity on a given track length. With the use of a scalable motor in mind, our cooling team implemented a water cooling system that uses heat exchangers 3D printed from aluminum to effectively cool our motor during operation. Together with our partner TSA, we discussed every detail of our motor to make sure that we can manufacture it to railway standards to ensure a reliable functionality through all operating conditions. But, kind of like in an electric car, energy storage is also needed to propel our pod forward. Therefore, we developed a high-voltage battery that contains 280 individual lithium-ion battery cells. Together with our partner Pulse Performance Drives, we were able to create an inherently safe system that can create power outputs of up to 60 kilowatts. That's actually comparable to a small electric car. Multiple safety systems continuously monitor battery health during operation, and if any error occurs, they quickly shut down the system. The power provided by the electric battery is then converted into alternating currents by the power electronics. A close partner from Karlsruhe supplied us with a lightweight system solution that proved to be easily integratable into our communication system and also flexible enough to use with our linear motor. Even if at really high currents of up to 300 amps, it ensures a safe operation of our LIM. But for all these components to come together, it needs a bit of substance, some sort of structure, and that's what Jonas knows all about.
Yeah. The main structure, or as we call it, the structural frame, is our main load-bearing system of our pod. all the other subsystems are attached to it, which leads to 35 interfaces for all our components there. Further, the frame serves as the supporting structure that withstands all the internal and external loads, especially all the influences induced by the unevenness of the rail. Therefore, we applied modern design criteria to our development process. With respect to scalable Hyperloop pods, we focused there on modularity, which led to a rib structure design made from aluminum. The combination of laser cutting, milling, and also welding then generates a synergy of the manufacturing methods. Our second focus then was set on a lightweight design approach. This was to minimize the required propelling energy and also to promote an efficient use of resources. We achieved this by the application of latest structural designing techniques offered by our partner Autodesk. With topology-optimized parts, as well as elements we developed with the modern generative design tool, it was possible for us to find suitable solutions for all our individual needs. And this finally reaches to our customized and I think very extraordinary frame design. But to be able to guide on the monorail, we designed two identical sub-assemblies, one for the front, one for the rear of the pod, and they are interchangeable. So this is also one aspect of our modularity. The lateral guidance system there consists of 4 carrying wheels that are pressed towards the vertical part of the rail and that prevent the pod from rolling around the monorail. Then our vertical suspension let the pod roll on top of the rail and also contributes to set the air gap between our linear induction motor and the rail surface itself. But the most important mechanical safety system is our emergency braking system. It lets the pod stop if any error occurs or if the service braking by our linear induction motor might not be sufficient. And that's why our braking system is furthermore separated itself in 2 redundant pneumatic systems that each actuate 2 EBS modules at front or the rear to get the pod standstill safely. Nevertheless, we need a control system to have a fully functioning prototype, and therefore we need a brain, which you now get explained by Periel.
When we consider the pod as an entire body, electronic system is the brain and the nerve system within the pod. Those software and hardware components are required to get and share information from different sources, process them, and operate the run. Throughout the pod, ECUs are located near their subcomponents and required to get and share information and do their own society. The entire electronic system has a highly modular and distributed architecture to suit also to future Hyperloop prototypes, which contains several control units. For the communication between them, a high-level CAN bus protocol called MuZero is developed and used. Our toolchain designed for automatically generating from central database and include all our parameters, errors, and warnings. During the run or operation, we always monitor safety-critical signals such as emergency brakes or including all high voltage and low voltage signals. Therefore, safety is considered as the main criteria in the design. The system is powered by 24-volt battery and is distributed by self-designed power distribution unit with 10 low power, 4 high power, and 4 digital channels. During the run, pod autonomously moves and just receives beginning commands from the ground station via our telemetry system. The entire pod is managed by a computational model state machine and makes the transitions during the run. We also have a navigation system with active position and velocity estimation with different localization sensors, and filtering techniques. With those, computes the pod on its own and being able to generate its own trajectory and stops before the end of the track. Beside those localization sensors, we also have 6 different pressure for the braking system and 12 different cooling sensors. As an example, to visualize the data from the limb. So, enough code, power, and signals from the internal components. I would like to give the word for our main and only external component to Marius.
Our pod, of course, needs a suitable enclosure. This season, we designed our aerodynamic shell fully scalable in our CAD system. In order to reduce complexity, it only consists of one single body. We also focused on a stunning new design, which you can see in just a minute, and we hope you like it as much as we do. Designing a good-looking shell is nice, but of course, and more importantly, it has to be aerodynamic. This is why we conducted a parameter study with over 40 CFD simulations. The goal was to reduce aerodynamic drag as much as possible. And in the end, we were able to achieve a drag coefficient of just 0.2. In addition, we tested a small subscale shell, 3D printed, in our wind tunnel setup. And this gave us a chance to validate our simulations. When it comes to the manufacturing of the shell, we put a special focus on the material itself. Sustainability is a guiding value for our generation, and therefore we decided to use natural fiber reinforced polymers for our shell. In particular, we choose high-performance flax fibers combined with an epoxy resin system, which has a relatively high carbon content from bioresources. We also combined it with a rib structure, which gives additional stiffness. Since this material was quite new to us, we invested over 4 months testing it. And in the end, we were able to achieve the shell by resin infusion and with a mold which was CNC milled beforehand. Compared to carbon fiber reinforced plastics, our solution has a significantly lower environmental impact. When producing flax fabrics, water usage, CO2 emissions, as well as energy consumption can be reduced by over 80%, with similar properties for stiffness and weight. So, after seeing all these individual components, their concepts, and the thought and engineering that has put into it, it is finally time to see it all together.
That is right, Marius. And I think you as the audience, you can see even from the last row of the Audimax and also watching from our live stream that we all are incredibly proud and beyond excited to finally be able to present our work of the past 10 months tonight together with you. Dear partners, dear families, dear students, ladies and gentlemen, welcome with us on stage our second Hyperloop prototype, Aurora. It's so crazy to all see it come into reality after all this time. And I think what's actually quite special to us and also to this unveiling event is that the prototype that you can see on my left, does not only have all its components assembled, but it also proved its full functionality during testing. Actually, about 2 weeks ago, we set out on a journey to Munich, but instead of visiting the beautiful historic center town, we only went there for one reason. The I-beam Hyperloop test track that is located at the TUM campus in Garching. And in the video that you will see in just a minute, you can see telemetry data from our pod. More specifically, the pod's velocity and also the output of our propulsion system. So let's see how such a test goes. As you can see, the pod stands there ready for acceleration, and it already accelerated up until about 13 seconds into the test run, where we reach a velocity of 97 kilometers per hour at about 150 meters down the track. To stop safely before the track ends, in this run we activated the emergency brakes to bring the pod to a safe stop. As Marina explained in the beginning, the Hyperloop concept is about minimizing friction by the use of levitating capsules. And you may have realized, so far we haven't really spoken about levitation so much. And we gotta be honest with you there, our pod Aurora, which focuses on the development of the linear induction motor, is not able to levitate on the aluminum rail. But see for yourself what comes next.
In the beginning, we had a dream. And together with our academic partners and partners from the industry, this dream came true. They support us with knowledge, helped with the material supply and the manufacturing. So they play a very important role in the development of our loved prototypes. So please welcome the director of one of the research groups of our premium partner SEW Eurodrive, the project manager of the EFOY campus, Dr. Frank Schönung.
Can you hear me? Thank you, Michael, for the introduction. Thanks a lot. I'm very glad to be part of this spectacular show you're doing here. Very nice. And I'm glad to have the opportunity to talk about why it's interesting for us supporting Hyperloop MuZero and how Hyperloop MuZero, things like that, can be part of our innovation and research process. But first of all, let's have a look how activities, our together activities, can look like between SEW and Hyperloop MuZero.
Today we are at SEW to plan the future of MuZero.
At our research day here at the SEW Digital Lab, we learned a lot about technical project management and gained some insights on how we can use it in our association.
Cooperating with an innovative and also value-driven company like the SEW is a great opportunity for our association.
My point of view, the benefit cooperating with MuZero is that we have an opportunity to show you guys what we have been doing for the last 9 decades, bringing up innovation, bringing up new products and solutions. And of course, we're interested in showing you what kind of bright future you can construct with us, you can build up with us. and we are always looking for smart talents who are willing to change the future and bring all their knowledge to work.
Yeah, what you saw were the research day, the MuZero research day in our digital lab in Bruchsal. And I'd like to tell you why it's interesting for us supporting Hyperloop MuZero. Let me start with a quote from our Ernst Blickle. He was the one who made SEW real big, and he said, people don't want products, they want solutions, which means we have to know the customer needs, and we in the research, we do everything right if we know the customer needs before they know it. And that's what we try to do, and if you see what we're doing as SEW, I think sometimes it works. SEW started with electrical geared motors, only the rotating geared motors, and added inverters, added controls, added solutions for the energy supply, for communications, and so we are a supplier for complete systems since, I would say, 30 years. And at the present, we even do complete applications with the end customer, which is, for example, the assembly line of automotive industry. And for that, we need a continuous innovation. And you need several approaches for this continuous innovation. And one of the approach we're doing is our research campus in Bruchsal. It's a location close to the main side of SEW in Bruchsal, but a bit independent. And it's not only a location, but it's a concept. It's a concept of a creative atmosphere where we do research projects, cooperative research projects with the KIT, for example, and other partners, where we do pilot projects, if a technology is ready to use or almost ready to use, where we do feasibility studies for the future solutions. And with these activities, we're developing new technologies. We make technologies usable for us and for our customers, and we develop new concepts. And from the very first beginning, we do this together with students, with their bachelor thesis, with master thesis, with internships, as a working student. And that's the way we manage to build up a know-how, which means the knowledge about the new technologies, but even the people carrying that knowledge. And that's very important, even in today, that's very important for us. And in my opinion, what you're doing with Hyperloop MuZero fits perfectly to our concept, and that's why we like and we're happy to support you. For me, that's another thing why Hyperloop MuZero is very important, because if you have a look where our solutions, our products are used today, it's everywhere where goods are moved. Where goods are moved within the plants, within the production, but all over the supply chain. And that's why we have to know how does the goods movement will look like in the future. And that's the topic we're doing in our research department. I think in production we're pretty far. We've got our mobile assistance systems doing transportation, assisting with the sampling processes, but we have other solutions all over the supply chain. For example, a logistics capsule, which is a standardized load unit, which is able to move and to load and unload itself on trucks or trains, for example. And in my opinion, a solution like a Hyperloop can be one link in the future in the supply chain. In the future supply chain, or better said, in the future supply network we need. Let's have a look on another research project. Michael already mentioned it, the EFOI campus. We're doing it together with the city of Bruchsal, with the KIT, the Forschungszentrum Informatik and other partners. EFOI means environmental friendly experimental urban logistics campus, and the idea is to provide new solutions for last mile logistics and for the supply and the disposal of complete quarters or accommodations, which is our campus indeed, because 250 people are working and living there. So that's the example we have a look on. What we want to do is building what we call a quarter depot. And the idea is every parcel should be dropped on the quarter depot by the parcel services. Will be picked up, the parcels out of the quarter, and the waste shall be picked up at this building too. That's the idea. And on the campus, delivery robots do all the transportation, do the deliveries, and do the disposals. That's the idea. So the accommodation, the campus is emission-free supplied. And the idea is, you have an app, you see, okay, there's another parcel for me. You can tell via app, please bring me my parcels. The parcels will be brought to you, and if you have got a dog, that's what you've seen in this picture, the box can be brought to your house during the day. Maybe besides it you have another dog for a waste bin that can be picked up automatically, or you choose the solution, the synchronous delivery, which means the vehicle comes to you carrying the box, which is mounted on the vehicle, on the robot, on the delivery robot, and you can just pick out your parcel directly out of the box mounted on the vehicle. That's one example of the research we're doing on our campus, on our research campus. And coming back to innovation, to this continuous innovation, what do we need? In my opinion, you need a science or a knowledge network. The world's too complex to do everything on your own. You need the creative environment. You need young, creative teams, young students. They need to be young. That's you. We want to work with you on that topic. With crazy ideas, fancy ideas, new ideas. And I think what's important too, to get an innovation out of an idea is to have some experienced people, old people maybe, and who have the courage to go completely new ways with you, which means you don't know where you will end up if you're going that way. That's the concept we're following. I believe in it, and I think we can say it works. So we're proud, I'm proud to play a small role in what you're doing here. I think it's spectacular. Congratulations what you achieved, and let's keep on innovating and researching together. Yeah, I hope we do. Thanks a lot.
Thank you, Dr. Frank Schönung. So you see, we are a little bit kind of curious, I think. So we dream big. Let's have a little sneak peek together with our partner MuZero Design on how the future may look like.
These visions, these concept studies are really important to us because like that we can get more acceptance in society and transport our vision into the world. And also, to be honest, during the last 10 months, it sometimes was also quite helpful to tell our family and friends why we're not too much available and so hyped and committed to this project. And probably there are also still some unanswered texts. You will get your messages tomorrow. Well, we at MuZero, we see the bigger picture. Yes, we have developed a fully functioning prototype in the last 10 months. Besides that, we also do research because to us it is really important to give the next seasons a solid basis to work on and to start with. Therefore, we do feasibility studies, simulations, and also bigger pre-development projects. To gain further insights on all of these, please welcome our man of scalability, Lars Ohnemus, and our research and pre-development technical experts, Michel Wernekohl, Marcel Viereck, and Marcel Grabherr.
Yeah, exactly. In addition to our prototyping efforts, we are also looking into full-scale systems, mainly through modeling and simulation. For example, we investigated potential strategies for Hyperloop infrastructure here in Europe. Here we focused on upcycling existing railroad corridors for Hyperloop traffic. Especially here, we think it's essential to seamlessly integrate new modes of transportation into existing infrastructure, keeping the investment costs thus low. Our simulation studies suggest that for an optimal velocity control, existing routes throughout Europe could be suitable for economic ultra-high-speed travel. So would you fancy a quote-unquote short trip from Berlin to Paris? Well, based on our calculations, this could take less than 2 hours and 40 minutes, which is significantly lower than both airborne and railway traffic. These and other research topics are usually conducted through student thesis in cooperation with different institutes here at the universities. So if you're at the end of your studies and you're looking for an interesting topic, we have you covered. The digital methods are especially key for those full-scale investigations, but their usage in the prototyping process is also advantageous. Here, they help to accelerate the development cycle. During the first 2 seasons, we equipped the different development phases with tools that helped us to prototype faster and more reliable. Many tedious engineering tasks, as you might be familiar with, during the concept, design and testing phases, can be automated, thus allowing our team members to concentrate on the important topics. Thanks to our partner Speedgoat, we can now also directly test our concept ideas without fearing hardware limitations. Using hardware in the loop, we can now develop and test electronic components faster and, more importantly, in parallel to our mechanical subsystems. Also, to build persistent knowledge in our association, we started developing a custom data management system that will provide upcoming projects with the data stepping stones they need. And a really great example on how to apply this philosophy to emerging technologies is our second prototype, which by now I think we have teased quite enough. So we are proud to now present technological insights into our demonstrator and the next step toward a holistic Hyperloop prototype.
Yeah, as a result of our pod development reaching its boundaries regarding effective levitation, we developed our EMS demonstrator. EMS, short for electromagnetic suspension, represents the concept of an electromagnet attracting to a ferromagnetic rail. This attraction allows then stable levitation through its air gap controller, which was our main goal for the season. The development of our EMS demonstrator was a roller coaster ride over 2 fully developed iterations in only 1 year. Everything started with our first iteration, the test stand, which helped us perform fundamental subsystem tests of our electromagnets and levitation control. The gained knowledge was then used to develop our second iteration, the EMS demonstrator. We decided on a hanging system with the magnets and the capsule underneath the rail segment. The overall structure of the demonstrator is given by the self-developed track, with the L profile used as a rail. The rail on top differs from the rail or the I-beam at the bottom used for the Hyperloop pod we used so far. For an adjustable structure, a modular and flexible structure is used. On top of the capsule, 4 magnets with a suspension are placed in each corner. Here, a mechanical decoupling is installed to ensure a safe and stable levitation of our decentralized control. A multifunctional guidance system helps to keep our capsule on track and serves as a mechanical safety solution when we are not levitating. Our 4 self-developed and winded magnets make our levitation by inducing the needed attraction forces. Each magnet can generate a nominal force of around 1,000 Newton. But to build up a functioning system, the right interaction of structural and electrical system is mandatory.
And therefore, the electrical system was built as the next layer of the demonstrator. As most of our team members gained their first big experience in such a big and ambitious project, both pod and demonstrator offer a playground for students. A playground that allows mistakes and setbacks, as well as it rewards team effort and the drive for the technology. As a good example, in an electrical system, perhaps the demonstrator, where mechanical and mechatronics engineers design and assemble electrical components, we definitely live the motto, what doesn't kill you makes you stronger. Over broken BCUs and fried sensors, it was a stony road until a functioning system. But hey, in the end, here we are, and we have a running system, which, by the way, even has LEDs. Powered by a 24-volt battery, the electrical system allows each electromagnet to be fed with currents up to 25 amps through the H-bridge motor driver. Next to this, the main sensing of the system is given through 4 distance sensors placed at each corner of the system in order to monitor the active air gap between the electromagnet and the rail. This distance information is then directly fed into the brain of the demonstrator, the levitation controller. As we've heard in the beginning, the main goal of this demonstrator is its levitation with an actively controlled air gap. That is where this control unit comes into play. Structured as a PID controller, each electromagnet is controlled individually as part of a decentralized control approach. In order to achieve active and stable levitation, a trajectory for the travel of the demonstrator is given as visible on the screen. With the measured air gap, the controller calculates a current that is necessary to generate the forces, the attractive forces, that are necessary for the electromagnet to lift up the pod to the wished distance and to follow the given trajectory. While this part of the demonstrator is the main research focus, it will continuously be researched upon building the most representative model of the system and find the most suitable parameters for the system and control unit. Until the point where stable levitation can be reached, we still have calibration, optimization, and fine-tuning to do. But today, we are beyond excited and proud to present you the hard work that was achieved by this amazing team behind the project. Please welcome with us the EMS demonstrator, Leviosa.
What an amazing show. Yeah. It's unbelievable what has been done in the last couple of months. Finally, seeing both prototypes in real life, after all hours of hard work and all the challenges we were faced with, is a really special moment. There might have occurred one question to your mind. Why do we have 2 prototypes in one season? In short, it's all about innovation. After introducing the linear induction motor in season 1 and the aerodynamic shell based on flex fibers and the hardware-in-the-loop testing in season 2, we want to keep up the ambitious and innovative work in the upcoming years. And next season is already going to be a very exciting one. We are going to develop the first ever Hyperloop prototype in MuZero history that is combining both levitation and contactless propulsion. All of that is going to be based on the EMS system and 2 years of pod prototype engineering experience. Additionally, we are going to develop our own Hyperloop track within our facilities. I'm curious, and I'm certain that you can already be curious. what's coming next in MuZero Hyperloop. Now it's your time. It's your time to work on cutting-edge technology. And now it's your time to build the future of mobility.
Wow, so thank you to everybody who presented their component, their subsystem today, for sure only as a representative for the whole team. Dear audience, now you have gained a really broad insight into the world of MuZero Hyperloop. We are beyond excited to go to the European Hyperloop Week next month, which will take place in Delft in the Netherlands. And there we want to show both of our lovely prototypes and also compete with other established teams. We exchange our visions, our engineering thoughts, and together we create an impact on the future of mobility.
Thank you that you celebrated today with us the unveil of our both loved prototypes. It was a pleasure to be your host.
And what a journey it was. All this only was possible because of all the people behind it. The passionate, the driven, and dedicated people. It is incredible to be part of such an outstanding team. Dear team, now this is your moment. Please enter the stage. Welcome to the people from the pod team. Welcome to the people from the demonstrator. All the members from C-Cubed. All our members from operations, our incredible board, and also because it was not possible to go on stage last year, our alumni. We are MuZero Hyperloop.
Lovely.
As you just saw, it's been quite a journey the last few months, and with a lot of ups and downs. And at this point, I just want to say thank you to the whole team for all their work and dedication they put in. It's been a really great journey to see us all grow together as one team, and during that process to see each of you grow individually. And with that...
Wow, that's awesome, guys. Yeah, we really did grow, but we did not grow alone. So I think that we had the honor to onboard so many supportive partners and sponsors on our way. And I'm really, really grateful for all the guidance and for all the financial and technical support we have from all of them. But sometimes it's not only about building something, it's also about showing something and having crazy LED lights. And therefore, guys, get up. Jonas, Niels, Felix. Here, Chris. Awesome. Yeah, this is your applause, and I think that you really nailed the event here, so I enjoyed it, and hopefully you too. Yeah, and last but not least, we also want to thank Bettinger Media, DroneFlow, and also Moya for all the provided video materials, for all the animations. because I think that altogether this was a great show, and yeah, I will feel the goosebumps later again when watching the live stream. So thanks for being here, and then you can...
Yeah, and lastly, one very important thing, I would like to thank our entire build-up crew who actually spent until 6 a.m. last night to get everything ready for today. And I suppose we will take until 6 a.m. tonight as well to get everything out of this auditorium again so that lectures can take place tomorrow. So a big thank you to all of you. But... And last applause, I promise. A big thank you also to everybody of you here in the audience for being here with us tonight. Thanks for that. I mean, if you build up and then no one shows up, it's kind of sad. So thanks to all of you for being here. As you might suppose, the presentation is now over, but the evening is not. We will be outside in the foyer from now on, so if you have any questions, if you still want to drink a beer or anything else, feel free to join us out there. Also, we will move out our pod and demonstrator out in the foyer so that you can take a closer look and maybe ask a few questions to our experts here. Yeah, and that being said, we need some space here to move everything out. So if you leave the auditorium now, make sure to use the exits at the very top. And I think that's everything organizational I need to say. So thanks again to all of you for being here. And let's have a nice evening together outside. Thank you very much.